Hi everybody, it's Mrs. Gifford here, and today we're going to talk about solving multi-step equations. So this is lesson 2.3, and after this lesson you will be able to solve equations with more than one step, using fractions, and also talking about consecutive integers. So let's just get right into it. So this is just a quick reminder of what Mr. Root talked about in the last lesson. For the 5 steps for solving any equations, the first thing we're going to do is draw that balance line. We're going to simplify both sides. That's combining terms, canceling things out, whatever we need to. Then move all the variables on one side of the equation. Do opposite operations to both sides to isolate the variable, meaning get it alone. And then plugging our answer back into the original equation to make sure that your answer is correct. I think this is the #1 best part about solving equations, because then you'll get immediate feedback as to whether or not the answer you have is correct or not. So let's just get right into this. Example number 1. Sorry about that. Example number 1. We're going to solve this for an unknown variable. So what makes today's lesson a little bit different than the previous is there's going to be more than one step that we have to do in order to make this work. So we have to ask ourselves, if I knew a value for a, what would I do first? I would add 7 and then divide by 8 to get my answer equal to 5. So I'm going to draw my line, and then I'm also going to say, okay, well, I don't know a, so what's the first thing I'm going to do? Well, backtracking, I'm going to multiply both sides of my equation by 8. I'm going to draw this line, and the reason why I do that is my 8's are going to cancel. Anytime you multiply by 8 and you're dividing by 8, that leaves you with a plus 7 on this left-hand side equals 5 times 8. Okay. And then we want to get that a to be all by itself. We go back to those steps. We're going to isolate the variable. And what's the opposite of adding 7? We're going to subtract 7. So remember, whatever we do to one side, we have to do to the other. And the whole reason why we do that is because we want to get that a to be alone. And so we have a equals, and then 40 minus 7 is 33. So we're pretty sure that solution is 33. And so now what we're going to do is take this 33 and plug it back in for a to see if, we're going to check our answer, to see if this really works. So I have 33, put that in place of a. I'm going to add 7, and I'm going to divide by 8 to see if this really does equal 5. So 33 plus 7 is what? That's right, it's 40. And then 40 divided by 8 gives us 5. Is this what we wanted in the original equation? Yes, it is. So we know that 33 is our solution. All right, let's go on to example number 2. So we're going to solve for the unknown variable here, and so we have 2/3 j minus 25 is equal to 115. So the same thing here. If we knew what j was, we would multiply by 2/3 and then subtract 25. So the first thing I'm going to do is draw my balance line. There isn't anything for me to simplify, so I'm going to go straight to doing opposites. I need to get rid of my minus 25 first, so I'm going to add 25 to both sides. Because again, whatever we do to one side, we have to do to the other. And that leaves us with 2/3 j. Again, these guys cancel. And then on the right-hand side, 115 plus 25 is 140. Okay, if you don't know that off the top of your head, again, you can go ahead and use your calculator. Whoops, better turn it on. 115 plus 25, and there's my 140. So then the last step that we have to do is to get this j to be by itself, and when a number is next to a letter, it means to multiply. So to undo that multiplication, we are going to divide by 2/3. And again, whatever we do to one side, we need to do to the other. One thing I would caution you to start doing is to actually use this fraction bar instead of the division symbol, because in my experience, or in our experience, some students treat this as a negative because they forget about the little division part of it. It's just one of those little careless mistakes to work with. So again, we do that because we want the 2/3 to cancel, and that leaves us just with j over here on the left-hand side. And then I have 140 divided by 2/3. So this is something I'm going to use my calculator for. So I have 140, and I'm going to do division. And then again, anytime we enter a fraction into the calculator, we want to make sure to use those parentheses. If we don't, that's going to skew the answer more often than not. So again, 140 divided by 2/3, and I'm going to hit enter, and my answer is 210. So I'm going to check my solution again. So I'm going to take my 2/3, and I'm going to multiply it by 210, 10, and I'm going to subtract 25. And because I'm running out of room, our goal is to make sure that it equals 115. So I'm going to grab my calculator again. The first thing I'm going to do, following order of operations, is 2/3 times 210. Again, I have a fraction, so I'm going to put it inside parentheses, and then times my 210. That gives me 140, so here's my 140. I'm going to subtract 25. Ooh, that's bad. 140 minus 25. Let me try that again. 140 minus 25. There, I got it. And again, if I need to grab my calculator, do so. I'm going to hit minus 25. And there I have my 115. Is that what we had in the original equation? Yes, it is. So I know that 210 is my solution. Okay, let's move on to example number 3. So we've talked before about consecutive integers. So what do we mean by consecutive integers? They are integers in counting order, 3, 4, 5. They're numbers right next to each other. When we talk about them algebraically, you can consider them as n plus 1, and n plus 2. That's because to go from 3 to 4, here's the plus 1, and to go from 3 to 5, there's the plus 2. That's why we label them as n, whatever number we're talking about, the next one, and then the next one. If we talk about consecutive odds or evens, then we use n, n plus 2, and n plus 4. That's because we're skipping, going every other. So let's do an example here with the finding 3 consecutive integers with a sum. What does sum mean? It means to add, of 21. So again, it's 3 consecutive integers, so I'm going to use n, n plus 1, and n plus 2. Because we're talking about the sum, we're going to add those together. So here's our original equation, n, n plus 1, and n plus 2 equals 21. So the first thing we're going to do, we're going to draw that line straight through, and then we're going to combine our terms. We talked about that already. We have 1n plus 1n plus another n. How many n's is that? It's 3n. And then I have my 1 and my 2. So 1 plus 2 is 3. Next thing we're going to do is do our opposite operations. So I'm going to subtract 3 from both sides. And I get 3n equals 18. And then again, when a number is next to a letter, it means to multiply. So to undo that, we're going to divide both sides by 3. And 18 divided by 3 is 6. So 6 is our solution. And like we've done with the other two, I'm going to check my answer. And I'm going to use the simplified version. Well, not check our answer. We actually have to find the 3 numbers. So our first one is n equals 6. And then if we have n plus 1, what's 1 more than 6, which would be 7. And then n plus 2 would become 8. And so then to check it, do these 3 really equal 21? So 6 plus 7 plus 8. Well, I know that 6 plus 7 is 13, and 13 plus 8 is 21. So those 3 integers work for us for the solution. Again, using algebra and solving it symbolically. So on to our summary. Take a few minutes to summarize today's lesson. What's the focus? One thing you learned, one example, and then one question that you have. Have a great day, everybody, and I guess just have a great day.